Students, this is the ALEKS help video for the Unit 2 Study Guide 2.4 to 2.6. So taking a look, number one, classify the four angles. All you need to do simply here is if an angle is less than 90, it's acute. So angle C would be acute. If it is greater than 90, you are going to be obtuse. So angle D would be obtuse. If you are exactly 90, of course, it is right. So angle A would be right, etc. In the figure below, follow the directions. So it wants two other names for angle 1. So we sweep angle 1, and you can call angle 1 using three letters, G, F, E. And then you can go the other way, back this way, E, F, G. Angle, E, F, G. Name the sides of angle 2. The sides are the rays, F, H. And FG. And they're raised. The vertex, of course, is simply F. Number 3, it says right here, FGJ, and it's important that we trace and sweep. Trace and sweep. Colors really make this helpful. FGJ, trace and sweep, is 153. And then angle 2, trace and sweep, is 89. And it's asking for the measure of angle 1. And of course, you can see if you sweep that it's simply going to be this larger angle, subtract that smaller angle. Number 4. The key to number 4 is to realize that you have a right angle, which means it's 90 degrees. We're told angle 2 is 36 degrees, trace and sweep, and we're trying to find angle 1. So of course, this is simply going to be 90, take away 36, gets you angle 1. In the figure below, ABD is 87. ABD is 87. Angle 2 is 2 times bigger than 1. So we're comparing angle 2 to angle 1. Angle 1 is our unknown, and angle 2 is 2 times. So when it says times, that's a multiplication. So if we're 2 times, it'd be 2x. If it's 3 times, 3x. Watch out for the phrase more than. For example, if it says it's 10 more than angle 1, that's going to be 10 plus x. So the phrase more than is a plus concept, not a times concept. And of course here you would do 2x plus x equals 87. Right here, ABD is 87, so ABD is 87. CBD is 42, trace and sweep, 42. BE, bisect, so the bisector here, trace and hatch mark with the bisector. Now, it's going to ask for certain things. Of course, ALEKS is going to be specific. It wants ABE, but I want you to be in the habit of just finding everything, and then you're probably just going to stumble across the correct answer. For example, If it says bisect, you simply take that and bisect it in half. Obviously, to find this green angle, we can do 87 minus 42. So just get in the habit of finding everything, which is 45, because when you do that, you're most likely simply going to stumble across what you need to find, which is that yellow angle, which is 45 and 21. And that gets us 66. All right. Vocabulary check here. Linear pair. Linear pair is any two angles that share a spine, make a line. They also make 180. Vertical angles, any bow tie angles directly across from each other, and all vertical angles are automatically congruent. So vertical angles are always congruent. So now for this problem, you're going to be working those vertical angles and linear pairs. So before you take a look at the algebra here, step one is to simply make note of what's involved. We have a line, we have a linear pair, which means we have 180. So that red is simply going to be angle plus angle equals 180. That's our thing equation. Things before algebra. What's also true is that this is a set of vertical angles, which means for the blue, over here, we're going to have angle equals angle is our thing equation. So you ask yourself, which one will help you solve for the variable? I can't use the blue yet because I'll end up with two different variables. So we're going to use the red because your variables will be the same. You circle, plug, chug, and we're going to end up with 5x plus 79. So here we go, that's 11x, 79, 24, this is 13, carry the 1, and this is 103 equals 180. Of course, 11x, subtract 103, that's going to get us 97 divided by 11. Let's see, is that 8? No, that's not 8. All righty here. Made a little mistake there. That's 77, of course. And so x equals 7. So here we go. Very important that you actually learn to plug stuff back in. So this is 5 times 7, that's 35 plus 79. So 35, 79, that's 14, carry the 1. That's 10, and that's 11. And so this is 114. This is 114 right here. So Z is going to be 114 degrees. So the trick to this is linear pairs add up to 180. Vertical angles are congruent. Second to last one. Dealing with a couple justification proofs. It's very important you take the time to actually mark it out on the diagram what's going on here. So we are told that PQR and TSR are congruent, which are the big angles. We're told that angles 1 and 3 are congruent. And we're going to try to prove, I'm going to squiggle it here, that angle 2 and 4 are congruent. So obviously at some point, you have to first say that little angles add up to the big angle. So you know that, and at some point, you're going to be subtracting an angle, taking it away. So both are involved, angles adding up to big angles and then subtracting one. So coming down here, let me just color code this for you. This is the blue angle equals the green angle plus the red angle. And we call that angle addition. So there's a drop-down menu there. This one as well, the blue angle equals the green angle and the red angle. And that's also called angle addition. Why is this true? If you look very carefully, it is given. Now watch what happens here. PQR, come up here. We're going to swap out PQR and we're going to put in 1 and 2. TSR, I'm boxing it. We're going to swap out TSR and put in 3 and 4. That's called substitution. I don't remember if ALEKS is requiring lines right now, but if it does, it would be, it used to, it would be lines 1, 2, and 3, of course. One is congruent to 3, that was given. You look at the only difference here, and we're going to swap out the 1 and put in the 3, and now you have a 3 on both sides. So this again was substitution. And that was lines 4 and 5. Remember, we have to subtract at some point. So we're going to minus angle 3 both sides. And that cancels and we get what you're trying to prove, which are the reds. And the reason there is called the subtraction property. I think on ALEKS it's addition / subtraction property. We'll do one more here. Some of these might be angles, some of these might be segments, but the properties are exactly the same. So again, mark on diagram, the big angle and the other big angle are congruent. 1 and 3 are congruent. And again, we're back to the same thing. These guys, question mark, why are those equal? Same thing, little angles add up to big angles. And then we're going to subtract. So angle addition, this is given. You see here, we swap this out, put that in, substitution, swap that out. Put this in, substitution. This 1, 3 is given. Look very carefully, these two steps, we swap out 1, we put in 3, again that's substitution. And then you can minus angle 3 both sides. And they cancel, and you get, again, what your target is, and that would be subtraction. And make sure you say property. It's the one with property, not real numbers.